Good evening. Myself, Dr. Rabindranath Jana, Associate Professor, Department of Chemical Engineering, William Institute of Technology, would like to discuss the topic transfer operation tool. This subject is basically for biotechnology department, and the subject code for this fifth semester, that is ESBT 501. In part of the syllabus, it is having in module 4 that advanced separation process. So in that advanced separation process, we will have the topic like membrane separation, dialysis, ultrafiltration, reverse osmosis, power evaporation, and electrolysis. Mainly in this tutorial, we will discuss about the membrane separation process. As you know, due to the advanced technologies, our lifestyle has been changed a lot. The drinking water quality mainly is earlier we generally from different ponds or say lakes or whether okay, sometimes we used to take from the tube wells. But nowadays in every house there is RO, that is reverse osmosis, that are different type of branded companies are there. That is for pure for water like that way. So many companies are developing the different that drinking water equipments. So we'll discuss about the different techniques behind this that separation process, membrane separation process, and most of the cases here in membrane separation process, that there is a membrane and it is designed in such a way that uh, it is only permeates most of the cases only solid molecule, only of water molecule, between solids dissolve to some extent. In most of the cases for drinking water, that TDS, the total dissolved solid quantity will be rather below 200. And there is also UV and other the nutrients. Most of the cases it's allowed. UV is killing the germs. Okay. Now we discuss the, the membrane separation process. It is the most important practically used modern separation techniques in chemical process industries. Many other the areas also it is being used. It has now attained considerable maturity to successfully compete with some of the traditional separation process. Here in the schematic diagram, we have shown a membrane, that is the Fermi membrane, that is there is some specific pore size, and depending on the pore size, it will allow the different molecules to pass through. And most of the cases are that the brown color was here is having the impurities or the solid, which is not allowed to pass through. In the green color ball, that is most of the cases the water molecule, it may pass through the membrane. So from the mixture of different molecules, for example, say for the salinide of water, the water from the sea level, we can filter it and we can drinking our water from it. And in other case, we also may separate air. As you know, in air there is nitrogen and oxygen. There is a little of the carbon dioxide or say water vapor. So the membrane, if we manipulate the membrane size in such a way that it will only allow that nitrogen, the molecular size of nitrogen is lower than the molecular size of oxygen. So through that the membrane, if we allow air to pass through in one side, that is that nitrogen will come, and as a return kit we will get oxygen. So in that way, we can get oxygen also from air. But as I have mentioned here, the cost of the membrane is very high, and the production rate is also very low. So in order to get more production rate and more pure component, we have another advanced separation processes. And that is most of the cases we have to apply high wear, high pressure, and in some case we will find that membrane is at the specific pore size which can allow only the admin. And if us to get more production rate, then we can add the module in parallel combination so that it will help to get the more and more production rate. So membrane is a thin barrier placed between two phases or mediums which allow one or more constituent to selectively pass through one medium to another in presence of appropriate driving force. Most of the cases, the driving force is pressure difference. In other cases, maybe the affinity, the vivacity, maybe other cases. So depending on the different driving forces, depending on the type of membrane separation, we can apply and we can get the filtrate. That so that the water or filtered which is very pure uh, and which is having definitely having smaller molecular size. This is why membrane is used for separation of a mixture. It is called then that's what is called semi-permeable. Means it only allows to permeate one of the constituents from the mixtures. So the same that's why it is semi-permeable. Contrary to the conventional mass transfer operation, the two phases which is uh, which transfer from one or species of us are not in direct contact of membrane. Here you can see the schematic diagram. So in one end we are giving the feed, that means a mixture of different solids or the liquid may be there and the liquid dissolved solid may be there. Just for example, in pure water, if we keep that the water in that our overhead tank here, and there is a membrane, and the membrane, the molecule water molecule mostly in very less amount of salt it will permeate, so it will come as a permeate section, and the molecule which is half size of the pore of the membrane, it is remaining in the solution, and it is coming as filtrate. So you can see that the feed enters into one of the components and flows over the membrane. One or more components in the feed diffuse or pass through the membrane and is collected from other component of the cell as the permeate. The stream leaving the feed component of the cell is called retentate because some of the substance it have weakened. The membrane may be porous or non-porous. A non-porous membrane is called a dense membrane. So there are actually different types of membrane separation process depending on the pore size of the membrane. So first one is microfiltration, next one is ultrafiltration, and then nanofiltration, dialysis, before electrodialysis, reverse osmosis, and then fire evaporation. They are mainly dependent on different sizes. So here is the schematic representation of different membrane separation processes, mostly then microfiltration, ultrafiltration, and reverse osmosis. We are trying to explain here, if you look at this is the membrane and this is the impure solution we take. Showing the impaired solution, there may be water or different types of macromolecules, bacteria or suspended solids, solid particles. In this one, there is the microfiltration process. In that process, the membrane size is maintained in such a way that there may pass water as well as some selected macromolecules or salts. For the colloidal particles or bacteria, other it is being retained, it is being rejected. So it is showing like that arrow, you can understand. So overall, say from microfiltration process, only water and selected micromolecules or salt may be allowed to pass through. In ultrafiltration process, you see similarly water may pass through and salt may pass through, but not the macromolecules. Here, even concentration macromolecules may be allowed, but here in that ultrafiltration, macromolecules are not allowed. Only salt may permit. Similarly, so the different type of suspended solids, okay, macromolecules, or cells, different type of colloid cells, they are differently being rejected by that membrane. Ultimately, for the reverse osmosis process, we can see that through the membrane only water may pass through. So, this is very suitable for our drinking purpose. And most of the cases now the different company, as I mentioned earlier, they have done the membrane in such a way that they will only allow water molecule. So these are the differences among the microfiltration, ultrafiltration, and reverse osmosis. So you can see that a common membrane separation process is what are their driving forces. We have feed, their separation mechanism, and reject species, permeated species, and application. When we look at this table and we try to understand the difference among the different photosynthesis. So for microfiltration, the separation mechanism is sieving. Okay? So the membrane there is actually acting as a sieving purpose sieve in separating, okay, by through the different size of pores. So in the feed, the liquid or gas containing suspended particles is allowed as a feed. The driving force it is normally the pressure difference. The pressure difference may be less than 2 bar. The rejected species it is zero point 0.1 micrometer to 21 micrometer. Permeated species the suspending medium liquids or gas, and the application of microfiltration it is separation of cells, sterilization of liquids and gas streams, separation of emulsified oil from water, purification of liquids regardless in food industries. Next one is ultrafiltration. So same way the separation mechanism is civil and that the heat is mostly the liquid. The pressure difference well to maintain to some extent more, say 2 to 3.5 bar, and the reactive is large amount, and the solvent that is being formatted low molecular solid is being formatted, and it is mostly used in separation of biomolecules, proteins, emulsions, disperse droplets, macromolecules, autopens. So same way we look at that reverse osmosis, the separation mechanism is solution diffusion. By the diffusion process only, uh, the solid is diffusing through the membrane. But here it is sieving. Earlier two cases, there are the sieving. Right? The feed is salt solution or seawater, and the driving force is 10 to 100 bar or even more. Rejected species, low molecular solids or hydrated ions. Permeated species is mostly solvent, and the application is desalination of seawater, brackish water, treatment of wastewater. So nowadays, as I mentioned earlier, this reverse osmosis technology is used to get the pure water, pure drinking water from saline and seawater. In the Gulf countries, as there is very difficulties getting the groundwater, and the quality of groundwater is not good one. So in the Gulf countries, they are actually using seawater, and then by using the reverse osmosis, they are getting drinking water. So in that case, in that area, the cost of the drinking water is high. Next one is the dialysis one. It's very important, and the separation mechanism is mostly the same as a solution diffusion and 3D solution. Then the driving force is the concentration difference, and the large molecules say maybe 5 to 15 Armstrong, and molecules from 50 to 10 to the 4 Dalton. They are the rejected molecules, and the formatted species, that is microsolutes in solvents, and it is used hemodialysis recovery of selected solids. So in hemodialysis means in human body, if the kidney is damaged, then most of the cases the dialysis is being done, and where the exchange of um, essential salt with that blood, and that have occurs. It may take 6 to 12 hours like that. Next one is for evaporation, and the mechanism is solution diffusion, where we use mostly liquid mixtures, and their driving force is activity difference, and ultimately many more different types of hard molecules can be rejected, and for production of absolute alcohol, also dehydration of solvents, removal of trace organic from water, these processes are used. In the formation, what we do is the membrane is there, and through the membrane, the liquid mixtures, one of the liquid, they are permeated on the other side, and on the other side, there is a huge vacuum is maintained. So the liquid once it is permeated, it will get vaporized, and that vapor is being collected, and it is being condensed to get the pure liquid. The next one is say gas separation techniques. In the air, to the that process gas separation, we can separate nitrogen, oxygen, like way, and it's very useful nowadays. Though there are more advanced technologies are there, mostly the gas mixture, that is in our case maybe say air, it will compress, and then it's fine, and depending on their boiling point, they are being separated out. But by membrane separation also, we may separate oxygen and nitrogen from air. If we manipulate the membrane separation in such a way that it will. Okay, this is all about today's class.